Welcome. In this video we're going to examine a decision problem using what's known as expected monetary value, or EMV. We're going to do it first in terms of the payoff matrix. We're also going to see a visual way of representing these problems using what's known as a decision tree, part of which you can see on the screen at this time. So in this problem, we have a company that's thinking of building a condominium complex, and they just need to decide should it be small, medium, or large in size. Now they have some estimates. They estimate if the demand is strong, that the profits for the three different sizes would be 8, 14, or 20. If the demand is weak, then the profits would be 6, 5, or a loss of 9 million, depending on the size. We also have, based on market analysis, we're estimating that we have a 0.7 chance of having strong demand and only a 0.3 chance or probability of having a weak demand. So the first thing we'll do is we're going to fill out this payoff matrix. Okay, on the left, in this column here, small, medium, and large, those are our decision alternatives. In other words, our choices. Across the top, strong demand and weak demand, those are known as states of nature. We call it a state of nature when it's not something we can decide on, it's just something we have to wait and see what happens. Alright, so let's take these numbers here from the problem and find where they go in the payoff matrix. The second sentence here says, if the demand's strong, the profits, so strong demand would be right here in the table. The profits would be 8 for small, and then 14 for medium. These are in millions of dollars, and then 20 for a large. On the other hand, if the demand is weak, that would correspond to the next sentence here. If demand is weak, our profits would be 6 for a small complex, 5 for medium, and a loss, so I'm writing it here as a negative number, loss of 9 million. Okay, so that is what's known as a payoff matrix. In order to do expected monetary value, we want to go and below this chart we want to put in the probabilities. So the probability for strong demand is 0.7. and for weak demand is 0.3. Now EMV, or expected monetary value, we're borrowing here from statistics, and statistics you can think of as an expected value as being, you might say, a weighted value, weighted by the probabilities. So what I mean is this. If we had chosen to build a small complex, we'll have a different payoff depending on what the demand is. We could get 8 or we could get 6. What we do is we take that 8 and that 6 and we weight them according to our probabilities. Now that would be done by doing 8 times the 0.7 and then plus 6 times the 0.3. Well, the sum product formula in Excel will do that calculation very simply for us. So we do equals over here. I have a column EMV. We look for sum product, and so we'll take the 8 and the 6, we'll go and we'll select them, do a comma, and we want those weighted according to the probabilities of 0.7 and 0.3. After I do this one, I want to copy it down for medium and large. So notice I want to, sometimes I say, nail down the probabilities. In other words, make them absolute reference. F4 is a shortcut way of putting in the dollar signs that make it absolute reference. And we'll click Enter. So that's 7.4 for EMV, again, as a result of doing 8 times 0.7 plus 6 times 0.3. We can do the other two by just copying that formula down. And we want the highest possible expected monetary value. And so notice in this problem it would actually be a tie. 2 of these alternatives would result in an EMV of 11.3. Oh, wrong click there. let's just highlight those, and let's highlight what they correspond to, a medium or a large. Okay, so getting a tie may not be the most common thing, but that's what this problem resulted in. Now let's look at this picture here. Sort of an alternate way of looking at this. It starts out with a square here. We use a square when we are making a decision. In other words, a square, the branches coming off of them, would correspond to our possible decisions. Now, of course, we had to decide between a small, a medium, or a large condominium. So I've taken these three arrows and I've labeled them small, medium, and large. Now, that's within our control. What's not under our control is whether or not the demand will be strong or weak. Now, whether we get small, medium, or large, we still then have to wait and see strong or weak demand. So for each of these, I have a pair of possibilities. Customarily in a decision tree, we use a square or a rectangle when we're making a decision, and we'll use a circle or an oval when it's something that occurs by chance outside of our control. So what I'd like to do at the end of each of these paths, in other words for these 6 endpoints, I would like to indicate what the monetary value would be. So here we, let me follow my cursor here, small condominium but strong demand. That would be small and strong, so I would want to put an 8 there. The other hand, small followed by weak demand, that would correspond to this 6 right here. So let's put that in. And similarly, just going down, medium followed by strong would be 14, whereas medium followed by weak would be 5. And finally, down at the bottom, large followed by strong, large with a strong demand would be 20. Large followed by weak demand would be a loss of 9, minus 9. Okay, so 6 different outcomes in this tree diagram. Now, we're going to do what's called a rollback, and a rollback basically uses EMV, and it works like this. Once we decided to build that small condominium complex, we have 2 possible outcomes. So what we want to do is sort of weight these outcomes to get an expected value for having purchased a small condominium. So what you can do is with each of these outcomes, let's list the probability that would be associated with it. So strong demand is associated with a 0.7 and weak demand is associated with a probability of 0.3. And the same thing for the others, right? 0.7, 0.3, since we're just repeating, strong followed by weak demand. So in order to get the expected monetary value for each of these 3 different sizes of condominium complexes, just like I did over here in the chart, we want to do a weighted average. We want to do, let me do an equal sign. It'd be harder to use sum product on this one because of the way it's written, but it essentially would be the 8. Here, I'll just click on the cell. So it would be 8 times the 0.7, and then it would be plus the 6 times the 0.3. And if we hit enter, we get 7.4, which notice is the same thing we had before. Let's just finish it off. It'll only take a minute. So expected monetary value, again, the result, 14 times the 0.7, and then plus 5, oops, wrong symbol, 5 times the 0.3. So that weighted average is 11.3, same thing we had earlier. And then finally for this last one, we know we should get 11.3. Let's just do the calculation. Be 20 times the 0.7 plus -9 times the 0.3. And again, we have 11.3. So the maximum would be the 11.3s, and that would correspond again to either having built a medium complex or a large complex. Okay, I'm going to sign out. Good luck.